to be here today. So I'm going to go ahead and get started because that's what I'm going to do, because we have a lot to cover today. We have a lot of information, but just I'm going to kind of put a blurb out there that we need to be completing our digital notebook every week. That's the only place that I can see that you're doing something, since I don't have any other like places that I'm asking you to do things. I really want you to like put things in that digital notebook so I know that everybody is doing something each week. It's a little disheartening when I look at those notebooks and there's nothing there. And so I know that there are people that are probably doing things. I just need like a little bit more physical representation in that notebook. Does that make sense? Yeah. I think that that's definitely what I need from everybody. All right, so now I'm going to share my screen. I'm going to pull up our daily agenda. So our agenda today is to complete our week 4 check-in, which I sent to you. Again, if you need another Chromebook from me, or not another Chromebook, a different computer, like if you only have a Chromebook at home, I need to know that this week so that I can get a different computer to you, because robotics kits are going out next week to the first group of people. So if you, there's another form on Google Classroom. I know there's so many different forms, but this one is the robotics kit health and information form. So you need to go on there and fill that out and pick a segment of time that you're going to get these kits. So it's either starting next 2 weeks, the 2 weeks during spring or fall break. Is that fall break? Yeah, fall break. Is it fall break or is it winter break? No. What, Thanksgiving break, sorry. Wow, my brain can't function right now. So the 2 weeks, 2 weeks after this, 2 weeks after Thanksgiving break, and then the 2 weeks leading up to the end of the quarter. So you'll get the kits for 2 weeks, and you get to pick which week you get those. Okay, so it doesn't matter which one you pick, you just have to pick one. All right. And then, so yeah, so those are my little kind of housekeeping things. Again, I need you to do those digital notebook assignments so I can see that you got the vocabulary, so that I see that you're getting the information. And also, if you didn't do the intro quiz, that is still up today. So the intro to robotics quiz is still up today on your classwork, I believe, but you need to fill that out too. Okay, so I gave you the whole entire weekend to do that. You need to get that done. All right, that's housekeeping. So today we're going to talk about gears. We're going to introduce gears. We're going to talk about gearing up and gearing down. We're going to introduce a interesting drag and drop digital notebook assignment, and then I'll get some questions and concerns. Not very long today, but a lot of like really good information. Okay. Any questions so far? No? Okay. Those of you that are watching, I'm just going to make a little point. Those of you that are watching, please email me if you have any questions. All right. So today we're going to talk about gearing up and gearing down. And so I'm going to pull up my, where is it there? So I'm going to pull up my presentation and we're going to start that today. So you are going to get your robotics kits and you're going to encounter a whole bunch of different pieces. So along with the hardware, the wheels, the brick, all this kind of stuff, you're going to get gears and different pieces that are going to be used for attachment. So that's also considered hardware. Actually, okay. So all this stuff is considered hardware still. And in your actual robotics projects that you're going to do, so you're going to get a whole bunch of different projects that you're going to do while you have the kit. You're going to use gears. You're going to make like little gear train systems. So they're called gear trains. where you have at least one or two different gears right here that you'll use to change your robot. Hello, wonderful robotics students. It's Mrs. A here. I realized that when I went to convert our Zoom recording this morning, that the PowerPoint that I meant to share during that class time didn't actually share on your end. So I'm going to do a quick PowerPoint presentation today on what a gear is and what the gear trains are. So here is our PowerPoint right here. We were talking about before that gears work together to create machines, and they help different things to happen, like in a machine or in industry. It helps things to be pulled, help things to be pushed through, and it can be used in a lot of different applications, like assembly lines, in engines, all those different kind of things. Bikes use gears. If you've ever taken a look at the different gears on your bike, and gears are used to change speed, change torque, which torque is another word for power, or change direction of the actual object. So in a gear train, you have two different kinds of things. You have a driver gear and you have a follower gear. So on this picture right here, there is a green driving gear that is attached to a motor. Sometimes that motor is an actual motor. So for instance, when you get your robotics kits, it will be attached to one of those large servo motors, or it'll just be like a little crank motor, little crank lever kind of thing. And then you have the yellow, which is the follower gear. So that is the gear, the final gear that's being driven. Notice how you have the green and the yellow, the driving gear, it kind of, the teeth mesh together and it creates like this opposite movement effect. So when you get your kits, you're going to be able to try those things out. All right, so here is an example of what driving gears do. Like I said before, the teeth mesh together. They go in opposite directions, and they're used to change different speed and different torque or power. But how do we figure out how it changes speed or power? Well, we do something called a gear ratio. So a gear ratio is the number of teeth on a gear. So these little grooves right here are all teeth, and then divided by the following gear teeth. So the first gear divided by the second gear. So it's basically a fraction problem or a division problem. So on this example right here, there are 8 teeth on this driving gear, this one that is the first one, and there are 24 on the following gear. So the gear ratio would be 8 divided by 24. Oh, whoa, that was interesting. So 8 divided by 24. So if you are looking at this and say, what does 8 divided by 24 actually mean? Does that mean speed? Does that mean power? Well, let me show you. So it actually means that it is less than 1. So if you take 8 divided by 24, you get a fraction that is equal to 1/3. So if you were to take 1/3 and actually create that into a decimal, that is less than 1. The fraction is less than 1 too, but you can do it that way. So a gear ratio that is less than 1 is gearing down. Gearing down means the speed goes down, but the power goes up. So think about it, if you're riding a bike and you're kind of going up that hill and you don't have enough speed to get up to the top of that hill, what you need to do is you need to gear down. That's where that really tough pedaling comes in. Your power goes up, but you slow down, right? It takes you long time to push those pedals and to get up that hill. So whenever you see a gear ratio less than 1, that's gearing down, and that's more speed. So this is our example that we just had. The green is the driving gear, and the red is the following gear. So you see how you have a really small driving gear and a larger following gear. That's usually what happens. But what if we want to change speed? Well, if a gear ratio is greater than 1, then it's called gearing up. So think more, up, like those kind of mean like the same. You kind of get the same vision when you're thinking about those things. So more, you're going up. That is going to be your speed. So think about like speed. You're going to speed up if you are gearing up. So for this example, the driving gear is 24. So it's just kind of switched. So this driving gear is 24. So it would be 24 divided by 8. Oh, goodness, that's a good 8. And then 24 divided by 8 is 3. So if you had greater than 1, it is going to gear up. And that's when you start seeing like very speedy, like assembly line machines, all the different factories, see those belts like really moving really fast. They usually have gears that are gearing up and increasing that speed. Okay. All right, so let's do a couple examples. So let's calculate the gear ratio for this one. We saw that earlier. It was 8 to 24. The ratio is 8 divided by 24, which is 1/3. 1/3 is less than 1, so we're going to gear down. So less, down. Okay, the gear ratio for this one, so 40. So the ratio would be 40 over 8. So you see this is your driving gear, this is your following gear. 40 over 8 is 5. So if you have something more than 1, it is gearing up. More than 1, up. And so that would be more speed. And then calculate the gear ratio for these two gears. 24 over 24, that's 1. So it'd be pretty balanced. It'd still be pretty fast, but it wouldn't have that a ton of power. Okay, so there's the gear ratio for that. 24 over 24 equals 4. So basically, you're just doing division. So you're dividing fractions is what you're doing. Okay? So that was the slideshow that should have been in your presentation. So I hope that this kind of clears up what gears are and that it gives you a little bit more of a visual. So yeah, thank you so much for watching this video. So this one has a driving gear that is attached to like a little crank. So this is the driving gear, this is the following gear. I want you to kind of predict what you think is going to happen with a smaller driven gear and a larger following gear. Do you think that ratio is going to be less than 1 or greater than 1? So let's see. So that one has larger So I'm going to post this video as well, but these different examples show how you can gear up for power, or I'm sorry, gear up for speed, or gear down for power. And when you get your robotics kit, you're going to have to do a couple of these examples. You're going to have to build a couple of these different gear trains. So that's going to be what you're going to try and discover when you do those. All right. So what are you going to do to show that you understand gearing and following and how they gear up? Well, you're going to have this assignment that I'm going to drop into your notebook. So it's not there now. It's not in your notebook now, but I'm going to drop it in your notebook. But if I can't figure that out, I'm still trying to figure out the actual add-on. If I can't figure that out, I'll just send a separate assignment with this on it. This is a drag and drop activity. So you're going to choose your gears. So for example, if you want to choose the 8-tooth gear that we had before, and then your following gear is 24, all you have to do is pull those pictures to those different areas. Now, for the ratios, a lot of people will just fill in and go 8 to 24. I don't want that. I want the reduced down ratio. So think about fractions. Think about how many times 8 can go into 8 and how many times 8 can go into 24. So the reduced down fraction would be 1 to 3. Is that ratio greater than or less than 1? If it's less than 1, you're going to pull the gearing down button over. If it's gearing down, then it's going to increase power. And you're going to pull the power over. Okay? So you're going to have 6 slides that you're going to create these fictional gear trains. Don't make it hard on yourself. Let me tell you this. Don't make it hard on yourself. Don't pick 36 and 16. No, don't do that. Pick something that's easy. So for example, this one has 40, so you can do 40 divided by 8. We know what that is. 40 divided by 8 is 5. That is easy to figure out if it's greater than 1. All right. So your assignment is going to be completing these slides and telling if the gear train is gearing up or down. Come back to this video if you have any questions. There's also a video that I have that I can link that's just specifically talking about this if you can't find it in this video. But I think that I'm getting to the end. What questions do you all have so far? A lot of information in a really, really small amount of time. Do any of y'all have any questions, you and Axel or Blythe? No? Okay. So what I'm going to do is I'm going to send this out either in your digital notebook, and I'll send out something in Google Classroom that says I did that. So you'll either look for the assignment on Google Classroom or you'll look for the assignment in your notebook. But I'll make sure that I tell that to you in the notification. Okay. So that's all for today. Again, this is your assignment, doing the presentation. Also, not doing the presentation, doing the drag and drop assignment, and then filling out that Google form for when you want your robotics kits. Those are the most important things this week. All right. If there are no more questions, or if you guys are good, then I'm going to close out for the day and I'll get that assignment out to you. But I hope you have a great day. I hope everybody is staying safe. I hope you all are enjoying this beautiful weather. Get out, take a couple deep breaths of the autumn air, and I'll see you all next week, okay? All right. Bye, Ewan. Bye, Axel. Bye, Blythe.